course, for the first time, usually at technology conferences. I am here to talk to you, that turned out straight probably. That's what I'm very supposed to do. Somebody who plans things would have done that. So I'm here to talk to you about Ember Data. And if you've been, for example, at the previous EmberConf a year ago, you will notice that in the last half year to a year, Ember Data has made tremendous strides and made huge progress. Because basically, from an anonymous source that has definitely nothing to do with your current speaker, I can tell you that EmberConf was basically a small gathering of Ember developers designed to troll community about Ember Data and why it was so broken a year ago. But since then, we have made huge progress. And I'm here to report on that and to teach you a little bit about Ember Data and some of the ideas behind it. So we are going to do it pretty straightforward. I'm going to talk a bit about where it came from, where it is now, and where it's going to. With the basic ideas of Ember Data as a data persistence framework, what I'm really hoping that you get out of this talk is not only, oh, Ember Data has these cool features, or I should use it, or you're so good at selling things that I'm definitely going to use it, or please never mention the words Ember Data again. I hope that my talk kind of gives you some of the core insights that we developed in the last year and a half or 2 years that we've been working on it. And then through those insights, you can think about more deeply about how data is structured and how it works in your app. But I've been terribly rude. I didn't even introduce myself. Hi everyone, my name is Igor. I work a lot with Adapar. We make a lot of open source things. You can see us at adapar.github.io. We made tables, we made charts, we made widgets, we made lots of things that we open sourced. And in case you didn't notice, English is not my native language. In case my accent didn't give it away or my hard to figure out last name. So if you have trouble with my accent, I just tough luck. At least until like Google Translate figures out how to do real-time syncing, and I can choose to have like a very deep alternative American voice and speak, and Google Translate will just translate from whatever gibberish I'm saying. But until then, you have to bear with me. And actually, I don't know whether you've seen, while we're on the topic of non-native English programming, that Stack Overflow recently started with its first non-English board. It's Stack Overflow in Portuguese. And I got in a couple of discussions with friends and colleagues about how starting programming without knowing English very well works. And actually, I started learning about computers, I started learning about programming when I was pretty young, when my English wasn't really fully functional. And that tends to have a couple of very interesting side effects. So for example, as I'm sure many of you started learning programming, wanted to make games. And I would get whatever magazines or books or whatever were available in Bosnia. Let me tell you, there are not as many as you might expect. But whatever were available, I would read them, I would try to figure out how big programs work, how games work. And I would often see things like, mentioned, for example, things like a game engine. And at that time, because my English wasn't that great, I would have to figure out, because they had all these technical English terms, I would have to figure out from the context what they meant. So when they said like game engines and like this new game uses the Unreal game engine, it looks amazing, and it looks something like this probably. You can see, barely see the pixels. I naturally assumed that the word engine had something to do with the way things look like, which seemed fine for a while, until a couple of weeks later, I tried to play a racing game, where you get to upgrade cars, you get to invest into them, and I was like, okay, I can deal with this. So let's see, put kind like this, so I'll be like, okay, chassis, I have no idea what that is, I'll look it up in a dictionary, and I'll be like, okay, that makes sense, I'll invest in that, that's pretty cool. Brakes, I know what brakes are, I need those. Engine, oh, I am so smart, I know what an engine is. It has to do something with the looks of the car. So I don't need that, I don't care. So that's the thing I'm going to save on. And then I spent a couple of weeks wondering why that guy over there was me. And cool side effect of, cool for me at least, side effect of learning programming before becoming fully functional in English is that I get my mind constantly blown by the semantics and ideas behind some of the technical terms we use. Because most words don't have any meaning behind it. Like a tomato is called a tomato, and there's really no reason why it's called that, it just is. If it's like small tomatoes are like tomato grapes or whatever, that kind of makes sense. I guess in German, words make more sense, but most words don't have any meaning behind it. And when you learn programming and computers from that kind of perspective, and learning from context, you kind of ignore the meaning behind words. So my mind gets constantly blown when, for example, a couple of years ago, I realized that the driver is actually called a driver because it drives the printers, it drives the hardware. And I've just been recently, as I've been preparing this talk, and I wanted to introduce the topic of Ember Data as a framework, as a data persistence framework, I realized that the framework is actually a great name for what frameworks do. Because they literally are a frame for working. They not only give you code to get started with, they not only give you things to use, they give your brain a way to abstract things and give your brain a way to think about ideas. So they also have lots of other benefits. You've seen it, Thompson Ikuda's talk at FluentConf. It was last time he talks about all the benefits that frameworks have. It also caused me to have to read all my beginning slides twice. But they have lots of benefits just in terms of making you more productive, making you a faster coder. But they also have other benefits. Like, for example, giving your brain abstractions and ideas about how to organize code and how to communicate your ideas. So, I mean, there are some other benefits. If you're crazy Eastern European, you can use frameworks to climb things. But mostly, they give you a way of reasoning about problems and way of dealing with abstractions. And that's tremendously useful. That's almost as useful as all the code and speed up that we get. And I think that it's easy to illustrate this with a really short story and a thought exercise. Because I've been looking through the schedule, EmberConf, and I've seen that there's an Angular talk tomorrow. So if you were to suppose that the Angular talk is actually just a ruse to keep us all distracted here while there's all 400 of us, while Google, because we kind of get in the battle of Angular recently, so I think like if we were to consider that Google just sent somebody to talk about Angular in order to distract us, so Google NSA can steal all our private keys and delete Ember copies everywhere. Like even if that were to happen, even if all the Ember was lost and all the source code was lost, because we used it, we would still have tremendous benefit. Well, I mean, they would also have to kidnap Yehuda because he could probably rewrite it now in a couple of days. But even if all Ember was to disappear, we would still have tremendous benefit from just having been exposed to it and seeing ideas in it, like components, like how Ember structures controllers, how it structures views, how the router works, and having given us those abstractions, that's tremendously useful. So I kind of want to approach the Ember Data from that perspective, from the perspective of framework, and I want to talk to you a bit about how does it think about the world and what kind of problems does it solve for you. So let's start from the beginning. Most frameworks, I hope at least, solve some sort of a problem. And they usually solve some sort of a hard problem, otherwise you wouldn't need as much code, you could use a small library. So let's think about a problem, what problems frameworks solve. And it's not always exactly clear what problem they solve. Because a typical conversation about technology works something like this. Doing X sucks. Hey, use Y so X doesn't suck anymore. And that doesn't really tell you, I mean, even if you use it, unless you read about or understand the ideas behind the library or the framework you're using, just using the framework doesn't tell you why it's so good. You might notice you don't run into the problems you ran into before, but you probably will not understand why that is. But unless you read about how Ember is structured and the core ideas behind it, it's not immediately clear why it gives you so many benefits over differently structured frameworks. So if you look at simple example of frameworks, is like, for example, handlebars. Handlebars have one of their core problems they solve is that you have too much logic in the view. So handlebars solve that to prevent you having logic in your view. You have Rails, you have too much repetition in your server-side code, you waste so much time repeating code, so let's not do that. Rails solves that problem. MongoDB solved the problem that turned DB. So I guess sysadmins need something to do, so that's why people use Mongo. But most of these kind of have core ideas that drive. I mean, honestly, if you look at the source code handlebars that written, the source code of Rails and Mongo, they're all driven by these core ideas. So I want to dive a bit deeper into Ember Data and see its progress that it made from early on to this day, and see how some of the core ideas changed. Because we definitely didn't get everything right on the first or the second try, but by this point, we're really close to the 1.0. So, Ember Data, a data persistence framework. If I was very obtuse, I would tell you it solves data persistence. And I would be like, okay, 9 minutes left, maybe I should tell more jokes. But it does actually solve a tiny bit of the data persistence problem, because, to be honest, data persistence, people have been working on it since the 60s, written a bunch of PhDs, and it's a very, very hard problem. And actually, I'm really excited. Tomorrow we have a talk by an academic who's going to give us some ideas about the new data structures that are being created. Though I put him in the slides, I'm super excited. But I recently found out he's not even a PhD, he's doing a master's. So I think it's kind of fraud, but should be fine. I'm still very excited. But if we ignore all the hard problems, all the data persistence problems that people have written PhDs, theses on, got the Turing prizes, we are left with a code and a software engineering problem of how we organize our front-end code, how we organize our code, how we organize our data, so it works, it makes sense, and that we can be productive with it. So it might be easiest to look at a couple of core Ember Data features, analyze them, and see how they changed from 2 years ago to now. Because these were all kind of core features of Ember Data since the beginning, but they all changed in subtle ways, or not so subtle ways, for, I hope, the better. So these are kind of 3 core features of Ember Data, or what it tries to do. Data transformation, asynchronicity, and caching. And those are pretty self-explanatory, so if you think about them while in water, I think they'll be very clear. So data transformation is very simple. Data comes in, you need to transform it from whatever source you have for it to make sense in your app. Asynchronicity, you have to deal with how asynchronous data is structured. And caching is a core feature of Ember Data. One of the main reasons model level frameworks exist in Ember, like Ember Model, Ember Data. All of those try to solve the caching problem for you. Where if you have a full stack front-end app, you really don't want to request models all the time because you still want your app to work without internet, offline, and want to be fast and explosive. So they try to solve the caching problem for you. So let's quickly go into some of these and see how they're structured, what problems they solve, and how they change from the origin of Ember Data, and what it tells us about Ember Data's approach. So what I think we realized recently, well, as we worked on this, is that these problems, yeah, everything's cached, hopefully, so Wi-Fi is off. So these problems are actually not the same. Some are harder than the others. So if you look at data transformation, is a pretty easy problem, at least to grasp. Data comes in, you kind of have to transform it, and it has to come out. Please don't tell, I hope Jolis is working on her part and not listening to me, because if I just say, hey, transforming data is pretty easy, I think I'm going to get trolled hard later. But asynchronicity and caching are definitely harder to think about, harder to reason, and we might need more features and ideas behind it to be able to use them. But let's start with the easy one. Let's start with the data transformation. So I was saying that problems can be easy or hard, and they can be also common or unique. Basically, if it's lots of problems that frameworks solve are common across all the user base. And that's why they solve them, because you can write the same code, the use code. But some of these are more unique. And we'll see soon, for example, data transformation is unique to your app. It's very tailored to how your API looks like, and it's a bit harder to write good APIs for those one-off cases. Which is why, basically, you should give we're trying to give developers more freedom in the problems that are more unique. So we have a really nice graph here. We can look at these features on a basis of how hard or easy are they to implement for framework authors, and how common or unique of a use case they solve. So easier problems should be locked down less, as I said. Because it does not, if you screw up an easy problem, it doesn't matter. Because it does not propagate to your app, it's easy to think about, you can fix it easily. If you drive yourself in a corner with a hard problem in your very complex app, then you're pretty much screwed. And that's why it's really important for framework authors to make the hard problems really locked down and have a very strong heavy path on hard problems, while the easy problems don't matter as much. Because even if you screw up, it's easy to go back. And we'll see some of the examples here. And also these so all of these features map really nicely to Ember Data's source code and to the parts of the source code that you care about. So for example, data transformation lives in the adaptive serializer, while the asynchronicity and the caching lives in the store and the models. And as you expect, you would normally be able and expected to extend the adapter and the serializer, because that's what you want to tailor to your own app. While the store and the models, you really shouldn't be messing too much with, because those deal with the hardware problems that you really don't want to customize as much, because they'll be much harder for you to, if you run yourself into a corner, they'll be much harder to reason about, and they'll be much harder to solve later. So let's start with data transformation. As I said, it's a pretty easy problem. Well, I don't really want to say easy, because if I say it's easy, then I guarantee you 5 minutes after my talk, somebody's going to come up to me and say, hey, you said this was easy. How come there's still these bugs in Ember Data? So I would rather say they're tractable. You can think about them, you can reason, maybe not easy, pull request welcome, but they're pretty approachable. And they deal with kind of basic features like the fact that you have, for example, a JSON for a user, or some sort of a XML, if you're really unhappy and if you see code like this, come talk to me to work for Alibi. But it basically deals with really common feature set that you even use in jQuery, use it in Backbone, is hey, let's take some kind of looking data and transform it so it's canonicized in our app. And the other part is that it deals with, so for example, here we got this user, we got its name, and yay, the slides are now ready because they're live. And the other part is that it deals with mapping models in a kind of RESTful way to routes. And this is also kind of easy. You might want to override it, and it's going to be custom to your own app, but it's a pretty easy problem to reason about. Which is why before, so this wasn't clear immediately. Before, if you look at Ember Data serializer and adapter, this is a part of how it used to look like. This is an old slide which I used to teach people how adapter serializer worked a year ago. And this is crazy. And even though now currently REST adapter and serializer might be a bit complex, you were before expected to work with these. And this is insane because these are easy problems. If we give you simple hooks, you should be able to override them no matter how. We don't need to give you as much structure. You don't need as much hand-holding because it's easy. These problems are contained. They're easy to think about, and you can work through them yourself. So, as Robert Judgment said this morning when I called him at 7 a.m., the hooks are now insanely better because we made them very easy to use. It's, for example, you have a normalized hook for any sort of a model, and you just say normalize, you get a hash, and you can take the hash and do whatever you want with the hash. You don't need to look at 20 crazy methods and figure out which one you need to use. You have one method that says normalize, and you do stuff there, and you just canonicalize it. Whatever kind of JSON, XML, SOAP, whatever you got, you can do it in normalize. If you need a bit more crazier things, you can use a stat single or stat array. But there are these couple basic core hooks that let you basically write imperative code like you would in jQuery, like you would in Backbone, because these problems are easy, people know how to do it, and they get very, very frustrated when they have to learn a couple of pages of diagrams like these, when all they want to do is make IDB start with an underscore. So that's what happened recently with the data transform, with the last 6 to 9 months, is that all the adapters serialized API got rewritten, so now it's much more easier, it's nicer to use, and delicious, I would say. But as I was saying, in the future, because we kind of got this nice API that lets you do whatever, thankfully, there's not as much work for us to do anymore here. So we might want to tighten up some APIs. We might want to clean up a bit. but there isn't as much work here, and this should be pretty good to go. So data transformations, easy. Asynchronicity, well, that's kind of harder, but luckily, if you read anything about JavaScript in the last year or two, you know the promises are, well, data transform, easy, I forgot that part. So asynchronicity, promises, I was saying, if you read anything about JavaScript in the last couple of years, you know that promises are super popular. They solve a lot of async problems, and basically, unless your Twitter handle starts with S and ends in Upstack, you like using promises, you use them often, and they solve all your problems. So I just have to say that I have 20 billion and one I really wanted to get a video of Tom saying, my name is Tom Dale, and I approve this message. So going back to asynchronicity, promises really help you to do this well. And this is a great example of what I was saying before, about how frameworks and libraries give you ways to think about the problem. Because Ember Data did its own kind of broken version of promises back when promises were just starting, and solved these problems in a really bad way, because we didn't have the mental methods of thinking about these problems that a good promise implementation gives you. So our code used to be crazy. It used to be, you do a user find, then you register an onload event. When the user loads, then you have to remove the onload event. All of this is gone. This was scrapped. It was a good first attempt, but it got even crazier with different materializations and processes. We switched to a completely async, promise-based implementation of everything, almost. And right now, all you do is you find the user and you deal with the user. If you save, you just solve problems you couldn't solve before. If you have dependencies between records, you can save one after the other. That's all fine. And in the future, what we're trying to do is we need to add promises and pattern up a couple more APIs and basically promissify everything so you can deal with async in a very basic way. So one thing that if you read the blog post about Ember Data, and if you didn't, it's online on Ember.js, so I don't want to go too deep into this. But currently, you have a notion of relationships being async or synchronous. So friends can either be async false, async true. This is going away because this was a bad idea, unfortunately. We wanted to give you a way, if you knew that your records were there already, if you knew that, for example, friends here were already loaded, we wanted to give you a way to access them directly. But the problem here is that, for example, there are many problems. A great example would be a features adapter. If you go online, you read about it, it says, if your API server is not ready, you can use the features adapter to begin developing Ember.js apps, and then later you can switch to a REST API. Sounds like a great idea. It's a trap. Because at least right now, the problem is that you're going to start, and in order to take it easy on yourself, you're going to start with all your relationships being async, and with being async false. And then with your features adapter, and then later you're going to try switching to the REST adapter, and all your code is going to break. And one of the core principles behind Ember Data is the changes to the API should not impact app code. If you change your REST API, if you change it from features adapter to IndexedDB, if for some reason somebody forces you to use Monroe, then those changes should not impact your app code. And these implementations broke that. And that's why you get rid of them, and all the relationships are going to be async. And what's more, so for example here, you always have to get friends and then do stuff. And what's more, even object add for has many is going to be async. So when you say friends.get0, object at 0, that returns the promise as well, which seems kind of weird, but it's actually really, really awesome because this is a very natural way to implement lazy arrays. So if you have relationships that have thousands of records, now you have a very easy way to reason about them and a way to implement them with promises so that they work really well. And so this is just an example of how promises are going to, so all the relationships are going to be promisified in the future. And this code seems kind of crazy. Like you'll have to do this imperative thing all over again. You're going to have a bunch of dents and stuff. It turns out if you're writing Ember, because Ember is so awesome and really easy to decouple things, most of your code doesn't look like this. Most of your code looks like this. You basically have different computed properties, you have observers. And these work amazingly with Ember Data promises. because Ember Data actually returns something called a promise proxy, where you initially return a promise, and later, when the data loads, it will forward all the requests, all the accesses. For example, if you try to get user friends, it will forward everything through the promise, and all your code that's written with computer properties, observers, is still going to work. It's explained in a bit more detail if you look at the Ember.js, Ember Data blog post, and you can see how you can easily keep your code the same while switching to an async mode of operation, having a bunch of new features, and at the same time being able to reason about your code in a better way. Right, so we're down to 2. So we figured out data transformation, we figured out asynchronicity. Caching is a really, really simple one. So, data transfers, as you see, they're an easy problem, but they're unique to every app. While asynchronicity is a pretty hard problem, but most apps, like, there's only basically a couple of ways to be asynchronous, and we can implement them all in Ember Data and give you nice hooks and primitives that we went through and solidified and like to use them. So caching, when I say caching is easy, I don't mean a general purpose solution that I'm sure that no one is working on, but I mean that a basic implementation of if you read about an identity map, for example, I use it like the whole idea of identity map and caching is that if you try to access the same records in multiple places in your app, you should get the same object. So your changes can propagate immediately, your objects can be saved in the store, and you can access them from wherever. So that seems pretty simple. Ember Bundle does this, Ember Data does this. I mean, this part of the code hasn't changed since forever because pretty much it's just a hash map where you access records based on their type and ID. So far we have data transformation, we have asynchronicity, and we have caching. We have all the main features that I promised you I'll talk about, but it still feels like, I kind of went through this, it seems kind of straightforward. It seems like, guys, we've been working on this for like 2 years. Why is this, what's going on here? And there are a couple of core thoughts that I want to talk about. Is that first, this is still pretty awesome. So yeah, as you can see, asynchronicity and caching are the hard but kind of common solutions area. But yeah, I was saying this kind of like seems, what have you guys been working on for 2 years? Because this seems kind of straightforward. Well, there are a couple of core ideas here. Is that the first one, standardized data retrieval is still awesome. If this was all that Ember Data did, it would still be awesome because you would get, if you had a REST API, if you have Rails, if you have any sort of API, you get a standardized adapter, and you're good to go within a couple of minutes, and you can access your data, you don't have to do anything, it's standardized for you. So even if the data transforms and promises were the only things it did, it would get a tremendous speed boost to your development. But there's a trick here, because if you think about data transformation, asynchronicity, and caching, by themselves, they're easy, medium, and medium hard. But I mean, what kind of hardness scale goes from easy to medium? And it's and obviously the problem, if you think about it, the problem is if you put all these three together, you get craziness. And that's kind of what Ember Data has been dealing with for the past year or two, other than making APIs nicer. Because if you think about it from a basic level, this seems easy. Like you get the user comes back. I like to compare it to a story where if I try to go to my parents' place to get a light bulb because mine broke. Also seems pretty simple. Except if I do that, I usually get stuck there for half an hour. I come back with a packet of light bulbs, lunch for 2 days, a new set of sheets, and a bunch of new things, and probably get a new exam scheduled to the doctor because I haven't had my blood drawn in a year. So if I try to think of REST APIs the same. Some of the REST APIs behave the same way because you have no control over them. You try to say, hey, find me a user, and the same way I try to get a light bulb from my parents, and it comes back all crazy. It says, hey, here's a user, but here's also a bunch of other emails, here's a bunch of other stuff, maybe some things came over a socket. All of the different kinds of things that APIs can provide you because you have no control over them. And this is the really, really hard problem because this can get even crazier. And I'd like to call this the problem of locality. That's the problem of, hey, data's coming in all the time, maybe through sockets, maybe through side loading, and it's impacting your models all over your app. Now imagine if you had a front-end framework like Ember that did that, where the whole idea of Ember as a framework is to scope changes. That one controller shouldn't impact another controller, that one view shouldn't impact another view unless it's directly scoped in their components. If this was the case, if Ember worked like this, that would mean that any controller would work
could impact anything. And this is how your data situation, if you don't think about it particularly hard, is. Because your data that comes in not only impacts your current request, but could impact your data throughout the app. And it gets even crazier. Because if you add relationships, and this is the part that, if you look at the talk description, this is the part that we have PTSD from. But if you add relationships, if you look at this, you have a post has an ID, has text and has comments. This seems fine. ID is 1, comments are 54. If you get more of them, look at this. You first get a post with comments 54, and then you get a comment with a post ID of 1. Now you have to go back and find a corresponding post and add this comment to the comments array. And this is just a simple example of how things go wrong when you have unbounded, crazy APIs that can push data to you at any point. And then you also have to care about merging. What if you have stale data? What if you have new data? So what Ember Data tries to do right now is basically make the store level, make the level that syncs this up together really, really solid and easy for you, so you don't have to worry about this problem as much. If you look at the Ember Data blog post, they also got a thing I'm working on. That's called a single source of truth. I'm out of time, so I have. If you read it or come back, or if you come later to talk to me, I'll be happy to explain to you. But this is basically going to fix the relationship syncing problem. This is a problem I talked about here. But then there are other problems that you're going to run as you develop your app. And then basically, what Ember Data is trying to do now, and one of the main reasons why it is so much better now, is that we basically focused ourselves. Basically, think about it like the core team's beard situation. It's the same way that it was transferred over multiple members of the core team, and they were all kind of medium. Now there's one beard there, but it's really, really good, and it's fantastic. So I'd like to think of the Ember Data the same way. Basically, we were focusing down on the core parts that are either easy and we can leave to the developers, or are very, very hard and important to get right. So your app, so you don't have to worry about it in your app, and then other easier problems you can solve yourself. So it's the asynchronicity and the caching problem and the locality problem down there. And locality is even more unique because it depends on your API. Your locality kind of depends on your data transfer, depending on how data comes in. And all these things together, so locality is really the thing that we're trying to solve right now. And it's looking pretty good. And if you use Ember Data, use its primitives, with all the promises and everything, it should actually kind of be straightforward and work pretty well for you. But that's why we had to scrape a lot of other features, because they were hard, they were causing problems, and they were actually solving easy problems and just causing trouble. So now, I think we're really close to shipping a 1.0, which is going to focus on a small subset and fix it really, really well, so you can be sure when you deal with your data that it's a proper state and it helps you reason about it. Well, thanks. I'm looking out the time.